Today's video is something anyone born in the last 20 years or so probably has no idea about unless they like their old tech. All PC gamers will know graphics chip makers Nvidia and AMD, previously known as ATI, but who among you recognizes the names Videologic, Imagination Technologies, Kyro or PowerVR? Funny thing is, quite a lot of you have probably had one of their graphics chips in your pocket in the past and you didn't even know it. Videologic started making graphics solutions in the 80s, and if you ever went into an arcade in the late 90s, you probably played games powered by their Naomi graphics board.
Hey, come on over, have some fun with Crazy Taxi!
They also provided similar graphics tech for the home market in the Sega Dreamcast, which was praised for its graphics capabilities. A few years later, they rebranded to Imagination Technologies and brought their third-gen PowerVR range of Kyro GPUs to the PC gaming market. After their hardware partners left the PC market, they transitioned to mobile phone graphics and were the GPU solution in the first iPhone in 2010 and most everything else Apple made up until the iPad Pro in 2017. Years ago, I had a Videologic Vivid XS Kyro II graphics card. No idea what happened to it, but I've wanted another one since. The card I'll be looking at today is a Hercules 3D Profit 4500, where you would see multiple board partners for ATI and Nvidia cards. As far as I can tell, the only two involved with the Kyro II chip were Videologic and the Guillemot Corporation, who produced the Hercules branded 3D Profit range of cards. While ATI and Nvidia had to include expensive high-speed DDR memory to deal with bandwidth problems, the manufacturers of Kyro-based cards had found a way around the problem and used regular old SD RAM, so it kept its cost down and was seen as a mid-budget card.
It's really like putting a fire hose full of water through a straw. We don't have that problem. We've overcome that fundamental limitation, and so our architecture is not limited by memory bandwidth. Therefore, our performance can go on increasing as the processor performance in the PC or the console or the arcade system increases itself.
Up until now, drawing three-dimensional scenes has normally been done one particular way. Make polygon wire meshes for each object, paint them with the right color, and then work out which bits you're supposed to be able to see with something called a Z buffer.
Most traditional systems use a polygonal model and use a Z buffer, which is a large memory system. Now, those two things together mean that the system is very expensive. We don't use any of those technologies at all.
Instead, PowerVR uses its own secret rendering code along with a way of describing shapes called infinite plane geometry. It's complicated, but the results are visuals that include correct shadows, atmospheric fog, and multiple light sources.
This is the start of a new era in the PC industry. And 3D technology really is only in its infancy on the PC at the moment.
On paper, it doesn't look particularly powerful due to the SD RAM, it doesn't have a transformer lighting capability, and there are only 2 texture units, but when playing games, it could keep up with cards that cost way more when it was released. One of the key differences about this card is the way it renders what you see on screen. For starters, it renders everything natively at 32-bit. I'm techie, but I'm not so techie that I fully understand the technology being deployed when it comes to GPU rendering, so here is an excerpt from the IGN Kyro II review back in 2001, which explains the difference to its rivals pretty well. The most interesting of the Kyro II's features, however, is its tile-based rendering structure. This is a method of HSR, hidden surface removal, that eliminates overdraw by simply not drawing anything that isn't visible on screen. While most video cards will draw an entire polygon even if only half of it is visible, the Kyro II will draw only the visible half. This saves rendering time and cuts back on memory bandwidth requirements. Essentially, unlike the big GPU vendors of the day which used immediate mode rendering to show the geometry and textures of everything visible on screen, including things you can't see yet, the Kyro chips use tile-based deferred rendering which breaks down everything in front of you into a series of tiles, then works out for each tile what needs to be shown and only shows you that. So it's a cleverer way of displaying the image using less brute force and so needs less power to do it. Anyway, first let's look at what won't work on the Kyro II, which is a lot. It's a DirectX 7 card with some DirectX 8 capability, so anything needing DirectX 9 is a no-go. That includes regulars I use like 3D Marco 3, Crysis, Doom 3, Fear and X3 Reunion. GPU-Z gives absolutely no information on the Kyro II at all. So, on to a selection of what does work, starting with the benchmarks. GL-Mark is a 2001 OpenGL benchmark from the German game developer Vulpine. Tested at 800 by 600, 1024 by 768, and 1280 by 1024, the Kyro II nets its first win, showing it to be faster than both a GeForce 2 GTS and Radeon 7500. GLXS version 1.2 is an OpenGL benchmark put together by Italian university student Paolo Martella in 2003. The GeForce card wins this round easily, with the Kyro II comfortably outperforming the Radeon card to come second. .3D Mark 99 Max needs no introduction for people who are testing their systems in late 1999. It's a DirectX 6.1 benchmark, and as it is a simpler test with a lot of the overdraw Kyro cards were designed to take advantage of, it absolutely destroys the other two cards, almost doubling the results of the Radeon 7500. Insanity 3D is a DirectX 8 tech demo by Lonely Cat Games with 4 scenes to choose from. I went with option 1, which centres around an Egyptian-style temple with some kind of alien tech inside. It seems to have been a rule that all benchmarks around this time had to have a temple with alien tech in it. Anyway, the GeForce easily wins this one and the Kyro II comes second, but not by much. Fog City is a random old benchmark I found which tests both OpenGL and DirectX. It has an alien ship flying around a very foggy city with its headlights on full beam. I chose normal mode for this test as it had enough clouds to cause problems for these cards. The GeForce wins again with the Radeon coming second, but not by much. DronesMark is an OpenGL benchmark from 2002 which looks like it wanted to capitalise on arena shooters of the time. It has some great music and the menu is navigated by a mouse-controlled alien hand prodding at selectable system options. The GeForce 2 wins again and the Radeon 7500 comes second. The tile-based architecture of the Kyro lets it down here, especially with the maximum FPS figures. It's no surprise that the Kyro II almost triples the scores of the other cards in Village Mark, as it's a PowerVR tech demo designed to show how the Kyro handles the overdraw of multiple textured objects one behind the other. There are versions in OpenGL and DirectX, and the GeForce is forced firmly into third place. I ran the Quake 3 benchmarking tool on high, where it ran each card at each resolution 3 times to generate an average FPS score. The Kyro is only 5 to 15 frames behind the GeForce, closing the gap as the resolution increases. At another step up, it would probably match it for performance. The ATI card comes in last, but is still fine for this game. I ran the Command & Conquer Renegade intro sequence at medium settings and captured FPS data from MSI Afterburner. The Kyro II does a better job at minimum frame rates, but is otherwise beaten by the GeForce card. There are no results for the Radeon card as it refused to run the game, but I tested again with an 8500 and that ran it fine. Half-Life 2, like all the game tests, was again run with Afterburner giving me the stats. I chose to test using only the intro scene as there is quite a lot going on for older cards to deal with. The GeForce card manages to come out on top, beating the Radeon, but the ATI card manages to get better maximum frame scores as the resolution is pushed up. The Kyro II doesn't do particularly well, though I'm surprised it actually ran the game in the first place.
The right man in the wrong place can make all the difference in the world.
Soldier of Fortune was run like Half-Life 2, with the intro sequence providing a challenge for all 3 cards and then jumping into some gameplay. The Kyro II wasn't able to keep up and was soundly beaten down by the Radeon card, which got better as the resolution increased. But the overall winner was the GeForce, which essentially doubled the frame rate of the poor Kyro card. Medal of Honor Allied Assault ran very well on the Kyro II, but not well enough to claim anything but last place in the tests. Its average FPS scores were enough to beat the Radeon, but as a whole it still came last with the GTS dominating. A lot of my friends preferred the Burnout games, but Flat Out was always my preferred racing game, as you could shoot the driver out of the car if you crashed. Flat Out was a bit of a disaster for the Kyro II, as it didn't do particularly well at any resolution. The Radeon card, even the low-spec version I used, is far more happy in this title, overtaking the GeForce while the Kyro II blows its engine block and limps off the track. Serious Sam, the second encounter, was finally another win for the Kyro II, with it beating both cards in all but a couple of examples of slightly higher maximum frame rates. There isn't a huge amount in it as it beats the GeForce 2 GTS, but a win is a win, and for hardware with such different specs, it's frankly amazing that the Kyro beats its theoretically more technologically superior competition. Unreal Tournament was only run at 1280 by 1024, but in both OpenGL and DirectX modes. As an older game, there isn't much surprise that the Kyro II does quite well, and in OpenGL mode it comes second behind the Nvidia card, although does beat it at minimum frame rates. When we change to Direct 3D though, the positions are reversed. This time the Kyro II wins, but the GeForce card takes the top spot for maximum FPS count. The last comparison test I ran was the 1999 Wonder Demo Scene demo entry by Team Sunflower. It's quite complex and I thought it would work well as a benchmark, so I used Afterburner to record the FPS scores again. The Kyro gets hammered on the low FPS count, being, at the least, doubled by the other cards, but its averages and high frame rate scores snag it another second place finishing spot. For anyone wanting to tinker, there is a handy overclocking option that the driver adds to display properties, and I was able to get it from stock 175 MHz to a stable 190. I tried 195 and then stepped down to 192, but it crashed. Honestly, there's not really much point in trying it for the sake of only 2 FPS. The tile-based rendering method employed by the Kyro chip line was certainly very efficient, but as soon as newer cards like the GeForce 3 came out with more pixel-pushing power, it was pretty much sunk. A Kyro 3 was planned, and it was supposedly going to have a texture and lighting engine to keep up with other GPUs, but it never saw the light of day. It also didn't help that an Nvidia rep supposedly sent out a memo to OEMs in an attempt to dissuade them from using Kyro 2 cards and instead used the tried and tested GeForce 2 line. I've linked to an article on this in the wordy bit below and included the PDF in a folder of drivers and PowerVR benchmark utilities I've used in this video, but here are some of the highlights. Nathan on Pixel Pipes and Phil at Phil's Computer Lab go pretty much over all the same things in their videos better than I have, so I urge you to check them out for some more info on the Kyro line of cards. I'm also including links in the description to review articles on the Kyro 2 if you would like to read up on more of the technical aspects of this card and its architecture. I'll leave you with the PowerVR Temple demo because, as I said, it's a rule.